So today we're going to talk about how we can work with classifiers in Qlucore Omics Explorer using the built-in machine learning capabilities. I'm Ann Holmberg from Qlucore, and I will guide you through this. So if you have any comments during my session, you can ask them, and there will be a Q&A session at the end. And I will also share the slides after this presentation. So a brief introduction here before I do the demo. So classification or predictive modeling is an example of supervised learning. Given some data and a sample annotation, the aim is to build a model from the data that is able to predict the value, the groups of the sample annotation in a new data set where we only get the data. And Qlucore Omics Explorer includes functionality, so machine learning algorithms, both for generating classifier models, the training of the classifier, and as well as using a trained classifier to classify one or several new samples in a new data set. And the machine learning algorithms that we support, the classifiers that we support are 4, so K and N, K nearest neighbors, support vector machines, random trees, and boosted trees that we call XGBoost. And we also have 2 methods for validation. So cross-validation using a part of the input data set or validation using a second data set. And why do we want to build a classifier? So we can have several purposes for that. The first and most common is to use the classifier to predict the class of new samples. And in the field of diagnostics, the use of a classifier to predict which group a patient belongs to is potentially a very powerful tool. And also in the area of precision medicine, the use of classifiers is interesting, both in the stratification of patients as well as defining which group the medicine should be targeted at. So if you have a subtype of a disease, maybe you need another medical treatment than if you have another type of the disease. So I will come back to that because this is actually something that we believe is very interesting. And another use case is an alternative way to understand the variables for a condition compared to just a statistical test such as ANOVA. So statistical methods will find variables that individually are associated with the predictor. So individually they are good at separating the groups of interest. But when you build a classifier, it's the combination of the variables that will predict the outcome. And you can build a classifier for any categorical annotation. So the prognosis of a patient, the response of or resistant to a given drug, subtype or different subtypes of a disease, and so on. Okay, so that was a little background. And now I will demo how this works in Qlucore Omics Explorer. Oh, I'm using the wrong cell. Okay, so in this example, I will show you how to build a classifier and to then use the classifier to predict the same groups in another data set. So I will use the built-in example data set leukemia subtype, and then I will build a classifier using the support vector machine algorithm, and I will also demonstrate the XGBoost method. And then I will use this classifier to predict subtypes in a new leukemia dataset, and that's also a public dataset that has been downloaded from Gene Expression Omnibus. Okay, so let's open the software. Here we have it, so hopefully you see it now. So let me just check if, okay, no comments in the chat. Okay, so here I will now open the leukemia dataset that's here in the help menu. Here we are. And in this data set, we have different annotations. For instance, we know which type of subtype these patients suffer from. So there are 7 different subtypes. If we color by those and just do an ANOVA test here on leukemia subtype, you will see that there are strong signals, big differences between the expression of the groups, which makes it possible to separate them. So we want to use this data set to build a classifier for identifying these groups, these subtypes in a new data set. So what we do then is that we go over here to build classifier like this, and then we use one of the support vector machines. I have 4 to pick from here like that. And then I want to use the annotation leukemia subtype like this. And I don't have an external validation data set, so I will just use the internal one here. And then we will do an internal cross-validation, which is quite extensive. And then we build the classifier. So I press build. And then I must give the classifier a name because we save it. So it's, I just call it class. We can call it even SVM like that. And I put that on the desktop. So now we are training the classifier. So it goes through a number of different variable combinations to establish which is the minimum number of genes that is required to get a good prediction of the good accuracy of the prediction of the groups. So that takes a little while. So there's a lot of calculation going on. So now we are evaluating the different options that have been identified, and soon we will have a report giving us the results here. So here we are, and we see that we needed 1,000, so where is my mouse? Here, 1,025 variables in order to get a good prediction here, a good accuracy. Here you have more details. Here we have the accuracy. So the accuracy is overall very good for most of the groups. We have one group where the accuracy is less fantastic. And if we go further down here, we have more details. And here we see which, well, combination of variables that have been tested. So 6 different outcomes, 7 different outcomes have been tested. And it found that we needed 1,000 variables in order to get a good accuracy. So, and these are actually probe IDs because this is a microarray data set. So here we have all the variables that are needed for this prediction, so that they are included in the classifier. Okay. And I forgot to show you there are also a lot of settings here for the different algorithms, features that you can set here for each of them like that. So you can do a detailed, you can configure it to your liking. Okay. In the next step now, we are going to use this classifier to classify the same groups in a new data set. And the data set that I'm going to use is a leukemia data set that I download from Geo. So let's do that. So you know that you can download data sets from Gene Expression Omnibus if they are stored in a format that we support. So I do that, and the name of the data set, I know it, so I type it in. If you don't know it, you can browse GEO, the GDS, the older curated data set, or the GSE, the newer data sets, for an interesting data set, and just paste the accession number in here. Okay, so now I download this data set. Which variable annotations do I want? I pick all of them. And that loads the data set. So in this case, we have 190 samples and 22,000 variables. We actually had, in the previous data set, we had 132 samples and also 22,000 variables. So they are probably analyzed on the same platform. So in this data set, if we look at the annotations here, we see that these are the 4 annotations that we have. We don't have any information about leukemia subtype. So let's use our classifier now. So then I move to the classified tab, and then I want to use this classifier. So this is the one that I just created. So that's what it suggests, but I can also load another classifier. And then which normalization mode do I want? If it's a reasonably big data set like this, it's probably the as data set that you want to use. If it's a very a smaller data set, you might want to use the normalization mode of the classifier. But I would say this is the normal, the default, most normally used. And then we just press apply here. And what happens then is that we create a new annotation with the prediction. So let's go and have a look here. So now you see that we have an annotation called leukemia subtype with all of the subtypes that we had before. And let's color by that. And here is the predicted groups. So if we can see that, and they also separate very well in this data set. Okay. So I also wanted to show you a classifier that is built with the XGBoost. This one. This is a bit slower, so I didn't want to demo the actual creation of the classifier to you, but instead I will use a classifier that I already built. So I will load, go and find it. Here it is. Like that. So now I use this XGBoost classifier, and then I also will get annotations not only with the different subgroups but also with the probabilities. So let's apply this, and then we get several new annotations: leukemia subtype 2, new prediction, and also the probabilities for each of the groups. So let's have a look on how that works. So here we now have leukemia subtype 2. So if we color by that, okay, this is the prediction of this one. Let's open up a new synchronized plot and maybe close the old leukemia data set and just tile these plots side by side. And now I will color according to the probability. So if I want to color by the probability of TALL here, so let's do that in this plot. Probability of TALL, which is the strongest signal, here you see. So red means that it's a very low probability that the sample belongs to the TALL group, and green means that it's a very high probability that it belongs there. So we have some very strong probabilities here, and we also have some weaker ones. You see that there are some that are darker green here, probability of 0.5, 0.6, but most of the probabilities are 0.9 and 1. So here you get a good view of the probability for each sample. So this sample, even though it groups together with the group, has a very low probability of it belonging to that group. And then we can do that for anything else. So if we want to have a probability for this group, see that we have it here. Maybe if we do a little, if we can separate it like that. So this is a very, very useful tool if you want to, if you have strong signals in one data set and want to use that knowledge on a new data set and see if you can separate groups based on that. So let me just check here. So let's go back to the presentation here and see what else I have here to talk to. So I will share the slides with you, and there are a lot of detailed slides here on all the different steps if you want to try to repeat this. The geoset that I downloaded, it's GUC 13425, also a acute lymphoblastic leukemia from 2009. And regarding, I talked about the usage of a classifier, and that is interesting to be able to stratify individual patients to see which type of a disease, a subtype of disease they have. And also this could be a help in precision medicine to establish which type of drug they want. So we are actually now in Qlucore working with a new product line where we have using the classification features that we have developed for Qlucore Omics Explorer in a new software that will be used for diagnostics to help doctors establish which type of precision or companion diagnostics, which drug a patient should use and what a type subtype of disease that the patient suffers from. So we have developed classifiers for a number of different diseases, and we are currently working with finalizing this and getting it on the market. So are there any questions? So please feel free and ask questions in the chat if you want. And while you are thinking about that, let me just talk about the upcoming webinars. So we will have a talk on genome browsing and gene fusions next week, and also how you can do very efficient testing with the biomarker workbench. And then we have a couple of other webinars later on, and we will fill this list with more webinars as the time goes. So we will always have a long list of webinars that you can register for. Okay, so if you don't have any questions now, I don't see any, so let me just check the chat, sorry. I don't see any questions right now. If you think about questions that you want to ask later on, just send me an email. I will share these slides with you after the webinar here. So by that, I would like to thank you very much for your attention today, and have a good rest of the day. Bye-bye.